Tonight's topic is permutation and combinations, and please change your notes to say day 2. The essential question is, can I find the number of possible outcomes depending on the situation? So our first example or situation is we have a coin that's flipped 3 times. So if you think about it being a coin being tossed, it could either land on heads or tails. A tree diagram is a systematic method for figuring out all the possible outcomes. So this coin is going to be flipped 3 times, so we start off with our tree diagram describing the first toss. So the first toss, we could either get heads or tails. Once that's determined, then you'll toss the coin a second time. So for our second toss, we could also get heads or tails, but it would depend on what we got the first time for what combination we have. So we would need to have show a tree to list the possible outcomes for the second toss. Now the coin is being flipped 3 times, so one more time. So the third toss, again, we could get heads or tails. But to see all the possible combinations, you want to list them out based on what the first and second was. Okay, so the total number of different outcomes would be, we could get heads, heads, and heads. Let's first list them out before we count out the total. And then we could get heads, heads, tails. And then we could get heads, tails, heads. And then we could get heads, tails, tails. We could also get in tails first, so it'd be tails, heads, heads. And then tails, heads, tails. And tails, tails, heads, and tails, tails, tails. So that is a total of 8 combinations of possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8. Or you could count down here with your tree diagram, 1, 2, 3, 4, 5, 6, 7, 8. So 8 possible outcomes, and the tree diagram is handy, especially if we have to then determine the probability of a certain outcome. In this case, they just want us to know how many possible outcomes there are. So there's a total of 8. Now our fundamental counting principle allows us to determine the number of possibilities per event trials. We can use multiplication to speed up the determination of the number of possible outcomes. So we'll look at one event and think of the top possible outcomes, then multiply by the second event, and then multiply by the third, and so on. Or if it's just 2 events, you would just multiply by the 2 items. But if we look at our example here for a weekend trip, if you pack 3 shirts, think the possible outcomes for the 3 shirts are blue, green, or yellow, and that would be a total of 3. And then 2 pairs of pants, you could have jeans or khakis. So there's 2 possible outcomes, it would be times 2. And then 2 pairs of shoes, brown and black. Now again, this would only work if everything matches. And since our jeans and khakis and our brown and black shoes are go with anything, I think this possible outcomes would work. So we have 3 times 2 times 2. And we have a total of 12 possible outcomes. Go ahead and pause the video and try your tree diagram and make sure that you agree that the possible outcomes would be 12. So you can see how the tree diagram shows all the 12 possible outcomes. And you can see how the fundamental counting principles speed up the determination of that. So you use multiplication and look at the number of event items. So 3, in this case, 3 shirts times our 2 pairs of pants times our 2 pairs of shoes, which result in 12. A permutation is a combination where order matters. Our first example here under permutation is assuming you can only use the letters once. How many different 3-letter sequences can be formed from the letters FUN, F-U-N? So the first possible number of combinations would be 3. We could start with F, U, or N. So using the fundamental counting principle, we know the first time we're going to pick, we have 3 possible choices. And then one of the letters is gone, so now we only have 2 possible choices. And then lastly, we'll only have 1 choice. So using the fundamental counting principle, we'll have 3 times 2 times 1, which will be 6. And let's make sure that makes sense to us. So 1 would be obviously the spelling we're used to, fun. The second one would be F would come first, but then N and then U. We could have picked the N first and then N, F, U, or we can pick N, U, F. And lastly, we could have picked U first and had FN, or U and N, F. So there's our 6 possible combinations. For number 2, order here matters. We have 8 finalists in a figure skating competition, and they are going to get to win gold, silver, or bronze. And the order matters. So the first to win gold, we have 8 possible outcomes. So it'll be 8. And then that person, once they win gold, they wouldn't be in the running for silver. So we'd have 7 people possible left to get silver. And lastly, both the gold and silver wouldn't be part of the finalists that are left to win bronze. So it would be 6 people left. So it would be 8 times 7 times 6, which would be 336. So that is using the fundamental counting principle. A second way to determine this is to use a formula for permutations. And this formula is again going to be on your quiz that you'll be able to use or on the SOL test. And it's NPRs, how it's listed, which is equal to n factorial divided by n minus r factorial. Now what n is the total number of people that you're looking at for the number of outcomes. And r is the number that you're going to choose to pick. Now if you remember what n factorial means, let's first plug in, it'll probably make the most sense. Let's plug in this question. So if we have 8 total finalists, so we have 8, and then we're going to choose 3. So n factorial, remember, is 8 times 7 times 6 times 5 times 4 times 3 times 2. So 8 factorial means you would multiply 8 and then count down, subtract 1 each time. So 8 times 7 times 6 times 5 times 4 times 3 times 2. And then n minus r factorial would be 8 minus 3 factorial, which would be 5 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1. So that would cancel with 5 times 4 times 3 times 2 times 1. And we would be left with 8 times 7 times 6. So you can see how you can use either the fundamental counting principle or a permutation formula for this problem. Either way, you're going to get 336. Now, if you look at these two examples, where we have 5 people applying to work at Harris Teeter, the store needs to hire 1 cashier and 1 bagger. How many different ways can these positions be filled? Now, in this case, the order matters. The cashier and bagger, they're going to be paid differently. They have different jobs. So here, the order would matter. This would be a permutation. And we would have 5P2 because the order would matter. In our second problem here, 5 people apply to work at Harris Teeter. The store needs to hire 2 managers. How many different ways can these positions be filled? Here, the order doesn't matter. If you get picked for manager, you're going to be doing the same job, being paid the same. So here, the order doesn't matter. So that's how this one is different. And what this kind is called a combination, when the order doesn't matter. Okay, so the Harris Teeter one, we're going to call it a combination. So it would be 5C2. And let's take a look at this example 3 and also the combination formula. So here, a team needs to select 3 seniors to be co-captains. Since they're all going to be the same job, the order doesn't matter. We're just going to pick 3 out of the top 7 seniors. So here, our order doesn't matter. If you're a captain, co-captain, which it would be different if we were looking at the seniors and becoming president or vice president or secretary. That order does matter. But here, they're all going to fill the same job of co-captain. So they're going to, order does not matter. And the same N and R occurs. The N is the total number of people or total number, depending on what the event is. And R is the number you're choosing. So here we have 7 total seniors, and we're going to pick 3. And it's going to be a combination. This formula is different. It's n factorial over r factorial and n minus r factorial. Okay. So if we're plugging in so we have 7 factorial over 3 factorial. And 7 minus 3 factorial will be 4 factorial. So 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Remember, 3 factorial will be 3 times 2 times 1. And 4 factorial will be 4 times 3 times 2 times 1. So to simplify this fraction, we can cancel our common factor of 4 and 3, also 2 and 1, and then 3 times 2 is 6, so that could cancel with this 6. So our total number of combinations would be 35, 7 times 5. Okay. There is also a third way to do these problems. And that is with a calculator. Now for the calculator, you will have to put in the n first, and then you'll need to put in, depending if it's a permutation or combination, NPR or NCR, and then you'll put the R in. Now where you find the buttons is math, then over to PRB for probability, and then you'll pick NPR or NCR. So let's take a look and see how that works. So first you put the total number, so it'll be 8 in this case, and then you hit math, over to probability, and then number 2, and then for NPR, and then 3. And that's how you can confirm your answer.